All right, let's practice our transformations, but with the cotangent function, which is really going to operate just like our tangent function. Just how we kind of set up our scale and how I visualize the period will be a little different because of that kind of shift of our graph. All right, so with this first one, we see that negative there, which means we're going to reflect over the x-axis. With that 3, that means we're going to have a vertical stretch by 3. So instead of those 1s and negative 1s, I'll be 3s and negative 3s. And then we're going to adjust the period, which again, the original period is pi. So we're doing pi divided by b, which is 2. All right. So with that, I'm going to put the y-axis here, x-axis, and I'm just going to use units of 1s here so I can see up to positive 3 and negative 3. And then with this case, so how we want to visualize the period will actually start at the y-axis because that's going to be an asymptote that we can start with. So if we had a phase shift, then I'd need to move it over. But with this case, since there's no phase shift, we're going to have an asymptote right there. And then the next one is going to occur a distance of pi over 2 away. And I use that same idea that this kind of distance of 4 squares is going to be helpful to us because of these special points that occur with our tangent and cotangent functions. So I'm going to do is set this up so that this distance of 4 squares from 0 is pi over 2. So right here is going to be pi over 2. Right here is going to be pi. You can see our pi over 4s in there if we wanted to graph those. But for each of those increments of pi over 2, we're going to have an asymptote. All right, so focusing on the 0 to pi over 2, halfway between those values, we'll be crossing the x-axis. And now typically it would go 1 to negative 1. But what we're going to do is stretch, and I'm even going to mark this with a special point because then we're going to reflect. But before we reflect, the stretch would bring this up to positive 3 and negative 3. But then the reflection over the x-axis means where it's positive, it's going to become negative. And negative is going to become positive. So you can tell it's starting to look like our tangent function, just with some characteristics of cotangent in there. So negative 3, 0, positive 3. And negative 3, 0, positive 3. And we could do one more over here. Negative 3, 0, positive 3. All right, and there's our graph. So we have our vertical stretch. We reflected over the x-axis, and we adjusted the period to be pi over 2 instead of pi. Okay, our next one here, we have all sorts of pieces to work with. So we're going to have a vertical stretch by 5. So those 1s and negative 1s are going to become 5s. We're going to, our period is just going to be pi, and I'm just going to make note of that for when we're in there, but that's not going to change. We're going to have a shift. And since it's plus pi over 2, that'll mean we're moving to the left by pi over 2. We're going to also have a shift down 3. So let's see, we're moving down 3 and stretching by 5. So with that, I want to see a little above the x-axis. I want to see up to positive 2, but we could focus this a bit more on below the x-axis. All right, I'm going to use these distances of 1 here. And basically how my x-axis behaves, you can kind kind of call this the midline, is going to be down at, I'm not going to use a red line, but it's going to be down at -3 now. So that's where the middle of these graphs will be hitting. All right, period of pi. So I'm going to do 4 units away is pi. And let's see, 2 pi, negative pi, positive pi. And we'll have asymptotes for every increment of pi, including, I get so excited making these asymptotes, but I need to remember the shift. All right, the shifting, where I would have my axis at 0, we're gonna move that to the left by pi over 2. So if this is negative pi, halfway between there would be negative pi over 2. So 2 squares is the equivalent of pi over 2. So that asymptote is going to move over there. And then we set this distance of 4 squares is the equivalent of pi. So I'm just going to set an asymptote every 4 squares. 4 squares. Okay, so that takes care of the shift to the left. We have our period of pi working. And so now let me think about those values that would be hitting the x-axis typically. So that's going to happen halfway between our asymptotes, but we move them down 3 units. So that's where I drew that blue line there, is that we're going to cross that blue line halfway between for each of these intervals. All right. Now with cotangent, usually goes, let me focus on this point here, that if we're to the left 1, we would be up 1. So that would be our like positive 1 value that we would be graphing. But instead of this distance of 1, we're going to stretch that to 5. And we go 1, 2, 3, 4, 5. And I'll be up there. And then similarly, where I'd have that -1, instead of this distance of -1, we're going to stretch that by 5. So 1, 2, 3, 4, 5. And then we'll have that for each of these intervals. And then we'll just graph them. All right. So, ooh, I missed that dot there, but close enough. Ooh, that got rough there, sorry. When they stretch out like this, it's hard to make them not look like a straight line, so just getting a little curvature in there is good. Sorry, I skipped over describing the domain for these just to get some extra practice there. So the domain for this one, x is defined by the x cannot equal. Now notice this is looking more like the tangent scenario, where we're shifted away from our y-axis, and actually this is going to be just like tangent, because I would be over at pi over 2, and then I have these increments of pi that are not allowed. So what I'm going to do is write this as we cannot be equal to pi over 2 or any added increment of pi, where k is an integer. All right, and then just to go back to this one, because this is one of those nice setups where you do have y-axis as an asymptote. So with that, we can just look at that pi over 2, and it's just any increment of pi over 2 is not allowed. So we have 1 pi over 2, 2 pi over 2, negative pi over 2, so on and so forth. So for the domain, I would say x is defined by x does not equal any increment of pi over 2, so it'd just be pi over 2k, where k is an integer. All right, so those are our transformations. So just a tiny bit different than our tangent function, but a lot of the same properties.